Hello, everyone. Thank you for joining today's joint webinar between Sedai and AWS on the top 7 strategies to optimize cost for AWS ECS. My name is Alex Sweetser, and I'm the Director of Technical Alliances here at Sedai, working with technical partners such as AWS to further develop the management in the market of AWS resources, including container infrastructure such as ECS. I am joined by Anush Sharma, Container Solutions Architect at AWS. Anush specializes in container segments in AWS and has been building on AWS for over 10 years now. He has hands-on infrastructure and application development for over 17 years. In his current role as a solutions architect, he leads co-building efforts with AWS and ISV partners to develop integrations that make partner products in AWS a better place to run workloads for mutual customers. I am also joined by Benjamin Thomas, President and COO at Sedai. Benjamin co-founded Sedai and built a platform based on his work managing millions of containers at PayPal in their payments production infrastructure. He brings a wealth of knowledge in managing containers and how to use ML and AI to autonomously manage cost, performance, and availability. Today, we will be covering different approaches to managing your ECS cluster. In today's cloud market, the majority of cloud adopters are using container-based infrastructure such as ECS. While ECS brings together favorable ease of use to containers, it is not without its complexities in managing cost, performance, and availability. Sedai and AWS have come together today to explore different options available to you to use in managing these complexities. If you have a question throughout this webinar, please put it into the Q&A section, and we will address those at the end. Also, stay tuned to the end to enter for more details on how you can confirm your participation for entry into our webinar raffle. Sedai has partnered together with AWS from a technical standpoint to deliver tremendous value to AWS customers utilizing ECS, EKS, or Lambda to autonomously manage their resource allocation through an application lens for improved performance, decreased cost, and heightened availability all in one platform. Our joint customers together are seeing as high as 50% reductions in cloud cost, 70% increases in performance, and as high as 6x productivity gains from their SRE and DevOps teams. I will now turn it over to Anush Sharma, Container Solutions Architect at AWS, to give us an overview of ECS.
Awesome. Thank you, Alex, and good morning, good evening. Glad to be with you all today to talk about this specific topic. So let's start with a quick primer on Amazon ECS so that we all are familiar with the terms that we will be further using in this webinar, and we are on the same page. So let's start with a cluster, right? And Amazon ECS cluster is a logical grouping of tasks or services. If you're running your tasks or services that use the EC2 launch type, a cluster is also a grouping of container instances. If you are using capacity providers, a cluster is also a logical grouping of capacity providers. When you first use ECS, the default cluster is created for you, but you can create multiple clusters in an account to keep your resources separate. Next, we have container instances. ECS container instances is a EC2 instance that is running the ECS container agent and has been registered into the ECS cluster. When you run tasks with ECS with EC2 launch type or an auto-scaling group capacity provider, your tasks are placed into your active container instances. Then there are task and task definitions. A task is an instantiation of a task definition that is running on the container instance or in AWS Fargate. A task definition is a blueprint for your task, which specifies the name, the task, name of the task, revisions, container definitions, volume information, and more. And finally, we have services. So ECS services enables you to run and maintain a specified number of instances of your task definition simultaneously in an ECS cluster. If any of your tasks should fail because of any reason, the ECS service scheduler launches another task or for your task definition to replace and maintain the desired number of tasks in the service. All right. With this, I'd like to hand it over to Benjamin to talk about the importance of optimization and take it up from there. Over to you, Benji.
Thank you, Anuj. Let me share my screen quickly. Okay. Thanks, Anuj. And thanks for that high-level overview on ECS and details on how AWS scheduler works in the back. Good morning, good afternoon, and good evening, everyone, wherever you're joining from. I'm Benjamin Thomas, co-founder of Sedai, and I lead engineering in Sedai. Talking about the importance of optimization. As engineers and engineering leaders, we all have different goals. Sometimes we have multiple goals. Sometimes we have one direction that we go on. Sometimes it's improving our customers' experience. How can you make things faster? Sometimes it's reducing cost. My performance is okay. I want to reduce cost. Sometimes it's a balance of both. So in today's session, we'll go on talking about cost optimization, but we'll try to keep a balance on how we can keep performance intact as well. What you're looking at is a case study that we did across companies who are using ECS. And the specific company is a security SaaS company, which is public. For every $100 million revenue, what we saw that approximately 8.6% was the cloud spent, huge amount, right? And if you could save 20 to 30% of that 8.6%, which means on an average, if you can bring down the cloud costs to 6% of your revenue, we saw that the company's bottom line profit grew a staggering 17%. So just by optimizing your cloud cost to 20%, you could see your profitability going up by 17%. So that's where cloud cost and performance optimization is critical. So I want to talk about the over-provisioning, under-provisioning problem to start with. Datadog did a study of across all their customers who are using containers. So they manage billions of containers. So what they found was that close to 50% of the containers use only less than 30% of CPU and memory. Close to 50% use only less than 30% of CPU and memory. That means 70% was wasted. So why does this happen? So typically, as engineering teams, we tend to be safe. We put a buffer. We want to solve for availability first, and for that reason, we just put extra CPU and memory. Sometimes you put up extra replicas. So that buffer is what is causing this big inefficiency. And another reason that I saw was companies sometimes have hundreds, thousands of services. It's very hard to right size each and every service. So there are buckets of compute profiles. There is a compute profile of 4 CPU, 8 GB that's used across 100 services. There's another compute profile of 2 CPU, 32 GB memory that's used across another 50 services. So these two were the two common reasons, being safe, and on the other side, having common buckets of compute profiles created this over-provisioning, under-provisioning problem. So in today's session, Anuj and I will go through 7 strategies to effectively optimize ECS specifically, even though some of these practices can be applied across container environments. So we'll focus on 7. By no means this is a very comprehensive list. There could be 8 or 9 or 10, but we think strongly, we believe that you should not miss any of these. Let me jump right in. So the first one is right-sizing your service. And when I use the word service, the task definition, Anuj was explaining that service defines how many tasks run, what's the connectivity, load balancers, stuff like that. And the task actually defines what's your compute memory profile is. So when I use the word service right-sizing, I'm kind of including task as well in the equation. So the first strategy is to eliminate over provisioning and under provisioning, right? So to save cost, you might adjust your provisioning. So you don't want to under provision also, that hits your availability. So the first strategy is to save, right size your service by eliminating over provisioning and under provisioning. So to do that exercise, as an engineer, what is a goal that you set for yourself? On one side, availability, you want to meet your application demands. And you typically have a typical traffic, you have a max traffic, you have seasonalities, you have unexpected spikes. So as an engineer, performance engineer, or a software engineer, or an SRE, you need to manage, for your application demands, not just today, even for future. On the other hand, wearing the dollar hat, you want to save cost. You don't want to waste a lot of resources. So that's kind of the balance that you need to manage when you right size a service, which includes a task as well. And when you do a thorough analysis of through your load test and through profiles, you could right size your service, and at sometimes you can also discover hidden opportunities where you increase performances as well. So let's go through some of the details here. So some of the challenges in right sizing your services, especially when you're dealing with many services, is each service is released. In today's microservices world, services are released very often. So each service has its own vertical and horizontal profile. Vertical profile is the memory CPU at the task level and the container level if you have a multi-container task. And the horizontal profile is the number of tasks that you're running. So that's one of the challenges that you need to solve. Number two, you had your goal. Okay, do I want to optimize for cost, or should I do I want to keep the cost the same, improve performance? And also I need to make sure all my seasonality is managed. So the approach to solve this is to right size your service based on your seasonal needs and production behavior. And at the end of the day, if you do that for each of your service, you can run your workload at the most efficient way. I wouldn't call it the most cheapest, most efficient way. So an example that you see here was a memory intensive application. But due to bucketing of standard compute profiles, initially the service was at 4V CPU, 8 GB memory, and needed 12 tasks, which the monthly cost was around $1,800 per month. So once you profiled it right, you understood that it's a memory intensive application. You were able to bump up memory. You didn't need a lot of CPU, and you didn't need a lot of replicas. So that way, you were able to reduce your cost by more than 30% in this case. And you sometimes get hidden opportunities where you save performance as well. Moving forward to the second strategy, you've optimized your service and task, and those services and tasks run in a cluster. And the cluster can be a Fargate back cluster or an EC2 back cluster. And Fargate back clusters are typically optimal. AWS provides you the right size. So this strategy is specifically focused on how you can optimize your EC2 backed cluster. So in the example that we discussed before, if we were to run 10 pods, and the application was a memory intensive application. So for serving a typical traffic that you have, and if you were to run 10 pods, and to serve that traffic, you are expected to run 10 pods. But in actuality, since it was a memory intensive application, if you had a higher memory profile, you truly didn't have to run those many tasks or pods. What you need is a lesser number of tasks, but with a higher memory profile. Once you do that, you don't need to run the same number of container instances or the same number of the type of container instance. You could choose a container instance with a higher memory profile, and you could run lesser number of container instances. That way, you save cost. And at the same time, by making that choice to pick a different profile, you have optimized your performance as well. So again, it's a win-win situation. On the other side, sometimes you could choose, you want to keep your costs the same, you want to increase performance. And in that case, you might give it more power, adding more CPU or adding more memory and stuff like that. So for that strategy, the key challenges is to identify first, go back to strategy one, optimize your service, and then identify the right profile of your container instance, and then use that and then resize and rebalance your cluster. That way, you save on cost and performance. Jumping into strategy 3. So we talked about optimizing your service, optimizing the cluster, the container instances that it runs on. So now, we've done that. Are we ready for the seasonal spikes? Are we ready for the complex traffic patterns that is coming through? That's where service and cluster autoscalers are important. So we have seen this practice where companies provision for the peak traffic that they get. So for example, around September comes in, and example is a retail company which gets Thanksgiving spikes. September comes in and you're already ready for Thanksgiving. You've put the maximum capacity that you need, right? Which is a cost burn for you. But that's not the ideal solution. You would want to keep your scale at the desired state, and you want to be ready for your seasonality patterns, your weekend spike. A retail company may have a Monday afternoon spike. A tax firm may have a different type of spike, right? So to manage your seasonality, you want to put the right autoscalers in place. You want to put your service autoscalers and your cluster autoscalers. And there are a few things that we need to watch for when you put autoscalers. You don't want your autoscalers to behave madly, right? So you need to make sure that you warm up your service continuously, but not extensively. Also, when you scale in your service, when you reduce your number of tasks, you want to do that conservatively and safe, right? So one example I've seen is an application that may take a startup CPU spike. If you don't put the right warm-up time frame, if let's say you have a 10-second warm-up time frame and your application takes more than 10 seconds to warm up, you're going to get the cycle of auto scaling happen. So you want to put the right warm-up values and right cooldown values in your scale out and scale in profiles. So that's the third strategy. So we talked about right-sizing your services, right-sizing your clusters, and put the right autoscalers in place. So comparing a before and after values, if you always plan for your peak traffic, you're always putting the maximum that you need, you end up spending more. But if you put the right autoscalers in place, you have a desired count, which covers most of your scenarios. And then you have a max and a min, and then you have scaling in place to get your max and scale down to your min when it's not required. Moving forward, enabling telemetry. It doesn't sound like a strategy. It sounds like a best practice, but we wanted to, Anuj and I discussed, and we wanted to call it out as a strategy because we have seen occasions where companies are not doing this extensively. Many times, companies only watch CPU and memory, and then they make decisions based on that. What happens is that performance is affected. Sometimes the error spikes go up. So we wanted to call this strategy out to observe your applications, your metrics, your events, your logs, and your telemetry. And when you make these optimization choices, make sure you've verified all these four, not just your saturation, but you've also verified your performance metrics, which is your traffic and latency, the events, and also how your dependencies behave using traces. Amazon AWS announced Service Connect last year. So a lot of these comes packed, feature rich by default with Service Connect. Your discovery, how you connect between services, and event performance metrics are available by default in Service Connect. So when you apply that strategy, the before and after picture is typically like this, right? So you have a before and after, which we talked about in the previous slides, but if you're not observing You don't know your performance. You're making decisions in the vacuum. But if you know your performance metrics, if you know your dependencies, if you know your events, then you compare everything and you're confident that the decisions that you have made are good and it works for your bottom line. All right. Moving to Anuj to cover the next 3 strategies. Anuj, I'll stop sharing right now.
Yeah, sure. Awesome. Let me start sharing my screen. Great. All right. So let's talk about the different purchasing options that we have available. So before we dive deep into this strategy, let's talk about the 4 different purchasing options available for EC2, right? Spot instances are placed as one of the 4 purchasing options available to customers when you are using EC2, which you all are probably familiar at this point of time. The standard on-demand pay-as-you-go by the second is best for fluctuating workloads from a cost optimization perspective. Reserved instances and savings plan, where you commit your usage in more or less flexible way in exchange for significant discounts. It's perfect for steady usage per se. And finally, spot instances, which constitute spare capacity in EC2 or Fargate, are available at very steep discounts for up to around 90% of on-demand prices. These are best suited for stateless or fault-tolerant workloads, and we will see why in just a second. Now, as you all know, when you run your ECS task, either in EC2 instance, where you as a customer have the full control over the operating system where your ECS task will be scheduled. Or you can choose to run in ECS your ECS task in Fargate mode, where AWS relieves you from the operational burden of managing and patching the underlying operating system and manage those for you. In both of these options, you have the option to apply spot pricing model. You get the obvious benefits of price in exchange to 2 minutes warning for reclaiming, but EC2 Spot specifically lets you choose the instance pool, whereas in Fargate Spot, you get a diversification automatically. Now, any of these purchase options that we just went through rely on the exact same underlying EC2 infrastructure available across AWS region, and there is no difference in the behavior of these instances, and Spot is no exception. Spot instances are just idle capacity that is not being used to fulfill the on-demand request, and they are made available at cheap prices. Very important to note here, although the price of spot instances changes in time, it is in no way determined by the highest bid anymore. Bidding is altogether a thing or a concept in past for spot. Instead, the price calculation now is based on the long-term demand and supply trends for the instances. Finally, there is only one difference between on-demand and spot instances. The word spare implies something, of course, which is that when EC2 instances needs the capacity back, spot instances can be interrupted. With the instance receiving a notice that termination will happen 2 minutes after the fact. This is why spot instances fit fault-tolerant or stateless workloads better, where an interrupted instance is replaceable with spot capacity when available, with little or no impact to your workload. Speaking on capacity, spot capacity is divided into what we call spot instance pool. Each of these orange squares that you see represent a spot instance pool. Each one is a combination of specific instance type, size, availability zone, and region. This really adds up to a lot of pools. The price and capacity of these pools fluctuates independently from each other. So if you use the same instance type on 3 different availability zones, you are effectively consuming capacity from 3 different spot pools. Tying this back to the spot interruption, it is easy to see that the more instance pools you use, the more diverse you are, which means that you decrease the chances of a large portion of your spot instance being interrupted if demand increases. It's kind of don't put all your eggs in one basket kind of thing. At this stage in the lifetime of Spot, with bidding completely gone and all the new capabilities we have, data shows us that the interruptions have become fairly infrequent, with only 5% of Spot instances that have been interrupted in last 3 months or so. The more customers adapt the best practices and properly diversify, the better Spot as a whole will function. As a good strategy, the best it's best to add a mix of on-demand instance and Spot instances. Even if you end up over provisioning, let's say by 50%, you're just by introducing 1/3 of Spot and remaining on demand, you are likely getting around 5 to 10% of saving in cost. Now let's cover how to implement Spot interrupt handling in ECS as a service, and let's see how that works in this area. The good news is this can be automated just by setting one parameter, which is ECS enable Spot instance draining to true for the ECS container agent on EC2 instance via user data during the instance creation time. This effectively drains the instances from ECS control plane and stops all the pending tasks which are scheduled on that instance. ECS does by setting all the tasks running on that instances to draining by sending sick term signal, let's say at T0, and sick kill signal 30 seconds after. This lets you stop your application gracefully or even do the last mile log collection. ECS will also deregister all the tasks from load balancer target group. And then ECS will try to reschedule the task on the remaining instances that you have available. Therefore, if I have to summarize this strategy, the implementation should consider architectural choices such as dynamically including a mix of on-demand and Spot instances, optimal multi-year commitment, designed to recover from interruptions, and most importantly, consider the profile of your workloads and see what kind of purchasing option can it fit in. As a sample calculation, just by introducing a mix of on-demand, Spot, reserved instance, or using savings plans, you are looking forward to get roughly around 50% reduction in the overall cost. All right. With this, let's move to the next strategy, which is tagging related. Now, tagging EC2 instances and your tasks enables you to get a full visibility on the cost. Each tag is a simple label consisting of a key and an optional value to store information about the resource or the data retained in that resource. Tagging addresses a variety of use cases, let it be like cost and finance management, operations or support, or even data management or access controls per se. For today's discussion, however, we will focus tagging for the cost and finance management use cases only. Cost allocation refers to the assignment or distribution of the incurred cost to the users or the beneficiaries of those costs following a defined process. We divide the cost allocation into two types, showbacks and chargebacks. Showback tools and mechanism help increase the cost awareness, whereas chargeback helps with the cost recovery and drives enablement of cost awareness. Showback is about presentation, calculation, and reporting the charges incurred by a specific entity, let it be a EC2 instance or a specific task on ECS, such as business unit, application, user, or cost center. It is important to devise a tagging strategy that addresses all your organizational needs, not only limited to like cost and finance management. So overall, your tags could be a combination of region, environment, let it be dev environment, prod environment, test environment, so forth, application tier, such as like middle tier, front end, database tier, or a specific unique identifier for that application, depending on how your organization is structured and the objectives, the overall objectives that you want to fulfill with tagging. All right. Tag enforcement could be either reactive or proactive, depending on the migration and the modernization journey that you are currently going through, and depending on which phase you are in this journey. Consider using tools such as tag policies or service control policies or IAM policies, etc., to enforce proactive tagging and implement these and implementing these typically have a tendency to break your existing automation for the workloads. Whereas reactive tagging, such as tag editors or AWS config rules or custom Lambda functions, typically do not break your existing automation. A combination of both of these worlds in terms of proactive and reactive tagging is considered best for effective tag management. All right. With that, let's talk about the final strategy, which is the schedule shutdown, and how that can benefit your cost optimization initiatives overall. Right. The benefit of cloud, in my opinion, comes from specifically from the costing standpoint, is best realized when you use the resources when you need it, and if you don't need it, don't use the resources, right? This effectively ensures that you are optimizing your OpEx versus comparing for traditional model of high CapEx per se, right? You may have a dev environment that you don't use it over the weekends or in the night time per se, right? Consider shutting them down if you don't need it. AWS provides solutions such as AWS Instance Scheduler, which automates the starting and stopping of EC2 instances. As an example, if you just consider shutting down your environment or your dev environment per se, which you may not use it over the night or over the weekend, it will result you approximately a cost saving of around 29%. If you operate just like 24x5, just 5 days in a week, when you compare it against running 24x7. So that by itself is giving you around 29% benefit in cost. All right, now we have seen the strategies. Over to you, Benjamin, to talk about autonomous automation and see how best we can implement them.
Let me share my screen back again. Thank you, Anuj, again. So now we have talked about all these strategies, how you could optimize for cost and performance. You optimize your services, your clusters, you do your telemetry right, tag it well, use purchasing options wisely. You could use your schedulers. The challenge is, okay, how best can you implement it? You could do it all manually. You could write your automation, and there are multiple levels of automation. You could write automation that is, again, manually triggered. You could write automations that's automatically triggered, but without any feedback loop. Or you could be autonomous, where you have automation, there's a feedback loop coming in, you learn from it, you understand the efficacy, and then you improve on your actions in the next phase. So we'll go through those details. So just to recap, we went through multiple strategies and different controls and levers that you could adjust to optimize your services. So these are things that are in your control. There are things that are not in your control, as people managing, engineers managing cloud, which is the traffic, seasonality patterns, and the releases that happen. So there are inputs and there are knobs that we could manage. And this defines the complexity of how you could optimize, how you could apply all those learnings that we talked about. So let me take an example of a company with 100 microservices. Average release is 1 time per week. Each of these microservices are released once per week, and there are different performance metrics to be analyzed each time it is released, and we are there are different seasonality patterns for the service. Even within a company with a specific seasonality, there'll be a group of microservices that follows a different seasonality. A retail company, it doesn't mean all the microservices follow the standard online purchase model. There are applications with different seasonality. So it's important to analyze the traffic seasonality and how they behave when we optimize them. So look at the staggering number of combination of knobs that you could adjust in the scenario. So that's where a higher level of automation or autonomous actions are more important. You don't want to just write random automation and leave it at there. You want to put all these things in practice, but you want to make sure that there are knobs in place to learn and improve on that. Again, ideal scenario is you have high level goals. Okay, what do you want to achieve for a group of applications? You have tagged your applications well. So for a group of applications, do you want to hit a cost duration balance? Do you want to improve performance? Do you want to decrease cost? That should be the goals that we operate on. On the other side, if you're managing with templates per service, you end up with hundreds of templates that need to be modified every release for individual services, and tens of services for your cluster autoscalers and your service autoscalers. So ideally, you don't want to shift left your production runtime responsibilities. You want to shift it up, where you have an autonomous system in place where it optimizes your runtime parameters. You still need your templates for your software versions, your dependencies, and all those things. But shift up is the right strategy to manage your runtime parameters. So again, a recap of, you could put point automation, but it will miss learning. The actual validation of your actions and how it behaves can be missed. You could enhance the automation to do that, but automation becomes autonomous when you do all 5 of these. So just to take you through, if you were to do this by yourself, typically you have a fleet, you have multiple services, they're all being observed well. That means the telemetry is perfect. Ideally, you want to build an autonomous platform where your topology is being discovered frequently. You're watching your metrics 24/7. That's being and every time you're identifying your app behavior based on the releases, you safely reconfigure them, optimize them. You identify what happened and validate the efficacy of the action. You learn from it and then keep repeating the loop. That's how a typical autonomous system works. With that, I will jump into a demo on Sedai. Sedai is an autonomous cloud management platform which will help you optimize your performance, cost, and availability autonomously. So I'll go through a quick demo. I'll escape the screen share. So I'll go through onboarding towards the end. I'll start with a view on how ECS clusters. Once an account is onboarded by connecting to the AWS account, all the ECS clusters will be shown. The actual cost of the clusters will be shown. And once you drill down into specific clusters, the cost opportunities at each level. So we talked about service optimization. We talked about optimizing the container instances and the different purchasing levers that we have. All those will be shown. So Sedai typically follows a crawl, walk, run mode by default. We are in recommendation mode, but once it is in autonomous mode, all these actions are taken care of by itself, which I will show in the next screen. So what we see here is for this particular cluster, for all the bunch of services that you see here, if you apply all 3 levels of optimization, you can achieve this much cost savings. So each service in this case were over provisioned, but each of them have a different configuration. And once they are all done, your container profile, your container instance profile is different. And the number of container instances that you need for your container instance are different. So you've optimized your services here. And once the services are optimized, you have the right profile of container instances. And then you have the purchasing levers that you need based on different commitment levels that you can give to buy that. So by doing all these together, you can save a large amount of cost. So this is how the recommendations will look like in Sedai once a platform is onboarded into Sedai. I'll go to the autonomous actions. So this is where you see the autonomous resource optimizations. As you can see, company with multiple services and multiple companies will have, so there are pages and pages of autonomous optimizations here. So it's hard for SREs to do this on a day-to-day basis because they'll be doing it all the time. But if you have an autonomous platform, the platform is going to do that for you every time when a software is released. So let me jump into a specific examples. And I know it's talked about tagging, right? So if you have the right tagging in place, you know what each each app group is doing. You know how much development costs, things like that. So and you could optimize, and you can have specific settings and configurations for each of them. So let me show you a specific example here. If you look at the service, this was optimized, and what happened is the latency actually came down. But we improved performance. At the same time, we saved cost by allocating the resources in the right way. Yeah, this needed less memory, but it needed more CPU. That way, you didn't have to run that many tasks. The fact that since we gave more CPU, the application was able to run faster. So you saved on cost as well as latency. So that's that. We quickly jump to how in Sedai you could set these goals. Once you're in the platform, once all the cloud accounts are added, for each account, optimization can be enabled, disabled. It can be in recommend mode. It can be in auto execute mode, and you could set the settings. Okay, I want to hit a balance for cost and duration. I want to decrease cost, but I don't want performance to take a hit. I want to keep the performance, degradation maximum at 2%. Or I want to decrease duration, but I want to keep a tab on the cost. So balance, cost optimization, performance optimization. All these settings are available in Sedai. And with that, I'll quickly jump to how you could sign up. So signing up Sedai is very easy. You go to www.sedai.io. There's a start free button. So we offer a free tier, which you could use, see the value, and then decide if you want to use it long term. So once you click on start free, you'll get a sign up page. I'll jump to, so it's a 2FA. Once the account is confirmed, you'll get a screen like this where you can select your AWS account. We support Lambda, ECS, EC2, EKS, as well as vanilla Kubernetes. So once AWS is selected and this option is selected, we'll walk you through CloudFormation template where you could attach the right role, and then Sedai will connect and identify your topology and start working. So it's very easy to onboard. Once onboarded, you put the right settings, and by default, we'll be in recommend mode. But once autonomous, we could autonomously take actions to optimize cost and performance. It works like an expert team of SREs who's working 24/7 for you. With that, Alex, I'll switch it back to you. Thanks, everyone. I think we are at the Q&A session.
Cool. Benji, could you bring the slides back up?
Yeah.
So we're going to be doing open Q&A right now. So if you do have any last minute questions, feel free to put those into the open Q&A. We're also doing a raffle. So we're going to raffle off 3 prizes, a $300 gift card, $150 gift card, and a $50 gift card. So all you have to do is confirm your participation by completing the survey at sedai.io/ECS. Or you'll be prompted at the end of the event to open the survey and take that as well. We'll be announcing the winner at the end of this week via email as well. So to start the Q&A, I'll send the question to everyone so everyone can see what we are answering. But with economic volatility in mind, is ECS service scale down, if necessary, as easily accomplished as scale up through Sedai? So Benji, I'll give you that one.
With economic volatility in mind, is easier service scale down if necessary as easily accomplished as scale up through Sedai? Yeah, answer is yes. And I think it goes to the fundamental principle that I talked also, right? When you scale down services, you want to make sure you don't do it abruptly. So you have your autoscalers in place, and your cooldown period should be the right one to manage your application startups. So you don't want to abruptly scale down. Same way to scale up. When you scale up, you want to make sure that the warm-up values are given right every service, and your desired and the max and min are put right. So yeah, the question is yes. And Sedai also takes care of safe scale down and a safe scale up.
Thank you, Benji. Anush, this one will go to you. Are there general guidelines on when to use Fargate versus EC2 capacity providers within ECS clusters?
Yeah, absolutely. So it all comes down to does your organization wants to get into the business of managing and patching your EC2 instances, or you want to offload using it to AWS Fargate, so that you don't get into that business altogether, right? Secondly, does your application requires elevated privileges? There are also considerations that you will need to make, whether your application requires elevated privileges on the underlying operating system or not. If you require elevated privileges on the operating system, what level of privileges that you require? So there is an option called capabilities that ECS Fargate offers. And you can go through that list and identify if you need any of those capabilities or not. And depending on those, you can choose to kind of decide whether you want to run it in Fargate mode or in EC2 mode. And iteratively, this should be an ongoing exercise, in my opinion, right? Whether if you want to optimize for cost, it should start with understanding or having a visibility in your operations also, as in how much you're spending on the overall operations and maintenance of the underlying EC2 systems, including people cost, any automations that you have done to automate that and so forth, right? And then factor that into account for considering AWS Fargate as an option or not.
Got it. Thank you, Anush. This one I think will dovetail into that question. With EC2, users have the flexibility to choose different performance tiers in that instance type, right? CPU focused, memory focused, network focused. But with Fargate, are there any general guidelines on how to optimally choose tiers for applications with different performance requirements?
Not sure if I'm following this question correctly, but again, as there is a limited options of what is available currently with AWS Fargate, right? It does not, you don't get a variable in selecting that, hey, I want starting X range to Y range. You will get like, I want X number of vCPUs and Y number of memory, right? And if it fits into your application profile needs, select that category versus selecting something else. And this gets back to the right sizing discussion, right? That you have to understand the profiling of your workloads and tie it back to the requirements of the underlying operating system or Fargate mode and select the instance types based on it.
Got it. Thank you, Anush. Benji, I'll throw this one over to you. How does this work in a large multi-AWS account tenants?
Yeah. So today we run customers who has one of our customers have more than 100 accounts. 100 AWS accounts. So how it works is, each account is accessed or added into Sedai on a role-based way so that it's safe and secure. And then once it's added, the settings that I was showing on how you would want to optimize can be controlled at the account level. And also to Anuja's point, if there are tags that are defined for business units, and if you want the chargeback and your goals are across accounts, for a specific business unit, then you have the right tag, right? You have tagged organizational unit or a business unit as a merchant, and you could change your settings just for a merchant, even the merchant is across accounts. So account level settings, group level settings, and even resource level settings, everything is available in Sedai. Yes.
Okay. And there's a clarification question on how does Sedai work within Fargate?
Yep. So the service optimization applies to Anuj also explaining to the previous question, right? So in Fargate, you cannot change from 4 vCPU to 3.6 vCPU. You can only change from 4 vCPU to 2 vCPU because that's the predefined bucket available for CPUs. And your memory also works in steps. You can only change from 8 GB to 7 GB. You cannot go from 8 GB to 7.5 GB. So Sedai considers all the Fargate buckets and it optimizes to that. So we consider the same, the steps that are available in Fargate, and we either step down the profile or step up the profile based on that.
Okay. Thank you, Benji. And can Sedai perform storage optimization?
Yeah, not today. So we are working with a few large design partners to optimize storage. Multiple areas. Same in storage. Also, you have the over provisioning, under provisioning problem, and most of the time it's the under provisioning storage usually grows, and there are cases when it grows and comes down also. And typically companies over provision. So we have seen this across our customer bases, and we are adding storage optimization features, which will come in mid-June next quarter.
Okay, thank you, Benji. I'm gonna reword this one a little bit, but when optimizing costs with Sedai in, say, ECS or Fargate, are there any risks that will limit the capability to handle abrupt peaks that could be handled if you had more CPU and memory margin left?
I see. Yep. So when Sedai optimizes services, we consider the traffic seasonality. We consider how the application starts up, how it performs at the peak, how it performs at the low level, how it performs on an average. And then we identify the right profile for the application. It doesn't stop there, right? We also add the right autoscalers in place so that when you get traffic that is growing, your autoscalers will kick in. And it also constantly does it. It doesn't optimize once and stops it, right? So every release, every software release that I reanalyzes the services. So if a recent release had a higher memory profile, Sedai would optimize that and then put the right appropriate autoscalers in place for that. So safety is one of our primary tenants. So that is handled in Sedai.
Okay, thank you, Benji. And I'll explain a little bit about our compliance too, to dovetail into this next question. The question is, how does Sedai manage Amazon accounts outside of the US or Canada, specifically internationally? Today, Sedai is SOC 2 Type 2 CCPA compliant. We do have international clients today, but Benji, I'll let you go into a little further detail about how we do manage those accounts.
Yep. So we have a separate SaaS deployment for our Europe customer and North America customers. We have, to Alex's point, customers from Europe as well. We have, actually, one of our customers is partly owned by the French government as well. So we have multiple instances of our SaaS instance itself where those international compliance apply.
And Highland just sent out a reminder for the raffle. If anyone wants to be entered in for the raffle, please just confirm your participation by filling out that survey at www.sedai.io/ECS. And it looks like those are all of the questions. I'll leave it open for another 30 seconds if anybody has any dying questions they want to ask. And while you take the survey for participation, if you want to try Sedai out for free to see how it can work within your environments, or at the very least, what recommendations it could offer for either performance or cost savings, you can go to sedai.io and try free, and we'll open up a free account for you just to test it out as well. We'll also be sending out the recording from this webinar to all of the participants. So if anyone had to drop off early, or if you wanted to go back and rewatch it, we'll make sure you have that resource as well. But thank you everyone for joining. We look forward to seeing you on the next webinar that we put on with AWS. Thank you, Noosh. Thank you, Benjamin.
My pleasure. Thank you, everyone.
Yeah, thanks everyone. John.